An important element of answer reporting in science and engineering is the accuracy of the number that is being communicated. So, for example, in the first statement here, we've got 4 different ways that 20 is being written. And in each of these circumstances, a different level of accuracy is being communicated. Now that depends on whether there's a decimal after that trailing 0 or not, or if there are any zeros after the decimal point. All of those circumstances are communicating something different. So what's the rule? Well, a significant figure is any digit 0 through 9. But for 0, it's a little bit trickier, and so we have a couple caveats. So 0 is a significant figure except for when it's used to fix the decimal point, meaning if we have a number like 0.51, the 0 is fixing the decimal point in that case, so it is not a significant digit. Or if we had 0.00785, all of those leading zeros are not significant. And then the other time zeros are not significant is if they are filling the places of unknown or discarded digits. And that really gets into the difference between these first two examples up here, the 20 with and the 20 without the decimal point. In the case of the 20 without the decimal point, what we're saying is that 0 is holding the place of a discarded digit, meaning it is not significant. So in this first one here, we really only have one significant figure. We're only accurate to the tens place. Whereas in the second example, by placing that decimal point after the 0, that's the way that we can communicate that that 0 is significant, that we are accurate to the ones place. So we'd say that we have 2 decimals, 2 significant figures. And then for the next 2 examples, those trailing zeros, because we have the decimal point and we're extending beyond it, are all significant. So we've got 3 significant figures here and 5 right here. So if you take a moment, go ahead and try this next set of numbers and identify how many significant figures it has. Maybe hit pause for a moment, and then you can go ahead and hit play and see how you did. So in the first one, even though there's no decimal point after the 6, all 3 of those digits are considered significant because none of them are zeros. We only need that decimal point, like we did here, to indicate that last digit or the trailing digits are significant if it's a 0. So we've got 3 significant figures there. In the second example, we also have 3 significant figures, because in this case, with no decimal point after the 62,500, we assume that those trailing zeros are taking the place of discarded digits. We only have 3 significant figures. If there had been a decimal point after it, then it would be 5 significant figures, but without it, there are only 3. For the next one, 5.701, that 0 that's in the middle of that number is significant, so we have a full slate of 4 significant figures there. In the fourth example, with no decimal point at the end, we only have 2 significant figures. And then for the last one, the number is 1,000,000, but with no decimal point at the end, we assume that only that 1 in the millions place is significant, so we only have 1 significant figure. What this is going to require of us is to retrain our brains when we do calculations to what our answer should look like. So in the example that we see here, we're dividing 20 by 7, but we're told that those numbers are not integers and are instead, they only carry 1 significant figure in each of those cases. Now, we're going to formalize the rules for multiplying or dividing numbers with a certain number of significant figures, or adding or subtracting, but just to kind of set us up here, the answer that we would have to report in this circumstance would be 3. Clearly, 20 divided by 7 is not 3. It is an irrational number that keeps on going forever and ever. But because of the nature of these 2 numbers, we would only have 1 significant figure. There's only 1 sig fig for us to report, which means we would have to round off our answer to 3. Now, in the case of numbers with trailing zeros, like we've talked about, those trailing zeros, like what we see here, would not be significant. So 33,600, the way it's written right there, only carries 3 significant figures. But maybe we want to report it to have 4 or 5 significant figures. So then that's going to require us to use some either rounding if we're going to have less than those 3 significant figures, or we're going to have to use scientific notation to communicate that those zeros are significant. So if I want to report this with 3 sig figs, I can either write it as is, or if we stick with scientific notation, it's going to be 3.36 times 10 to the 4th power. If I want 4 significant figures, the way I'm going to communicate that is 3.360 times 10 to the 4th. And so this follows the rules that we laid out earlier, that trailing zeros after the decimal are considered significant. So that's how we can communicate that we want 4 significant figures in our answer rather than just the 3. If we want 5 significant figures, then we're going to expand that to 3.3600 times 10 to the 4th. You can imagine if we needed more, we would just keep on increasing the number of zeros after the 3.36. Now, if we want to end up with just 2 significant figures, we're going to have to round that number off. So 33,600, we could write that as either 34,000 if we want to write it in standard notation, or of course in scientific notation, that'd be 3.4 times 10 to the 4th. We just have to be careful not to include any of those trailing zeros, because otherwise we'd be increasing the number of significant figures. And then the last one, if I want to report 1 significant figure, we're going to round off to the nearest 10,000. So we're either going to have 30,000, since that 3 rounds us down, or it would be 3 times 10, that is a 3 there, believe it or not, times 10 to the 4th power. So what are those rules for adding and subtracting numbers that have a specific number of significant figures? Well, in the case of addition and subtraction, we're going to add or subtract the numbers as they are, but then we're going to round based on the least accurate number in the operation. So if we look at the first example, we've got 201.144, so that's accurate to the thousandths place. Plus 1.05, that's accurate to the hundredths place. So the first number is accurate to the thousandths, the second is accurate to the hundredths. So we add those numbers as they are, and we get 202.194. But now, because this number was only accurate to the hundredths place, we're going to have to round off our answer to the nearest hundredth, which means we're going to look at the 4 to figure out what we do with that 9, and so indeed we end up with an answer of 202.19. So our final answer here has 5 significant figures. The curious aspect of this is that neither of our original numbers had that many significant figures. That's a difference from our multiplication division rules, which are a little bit cleaner and simpler, as we'll see in just a moment. So for addition and subtraction, you can end up with a different number of significant figures than you have in either of the original numbers in the operation. So at this point, you may want to pause and try these on your own, and then play the video to see how you did. But like we did on the previous question, we're going to perform the operation with the numbers as they are and get that answer, and then sort out what we need to round to when we're finished. So if we subtract 509.1 minus 201.12, we get 307.98. And now we look at the original 2 numbers, and we can see that the first one was accurate to the tenths place, the second to the hundredths. So that makes the one that was accurate to the tenths place the least accurate of those numbers, so that's the place that we're going to have to round to. So we're going to have to round to the nearest tenth. In this case, we have that 8 that is trailing it that's going to round us up, so we're going to end up with an answer of 308.0. We don't want to forget the 0.0 in this case because we are accurate to that nearest tenth, but we just got rounded up to the next whole number, and so we can see that we end up with 4 significant figures in this one. For the next question, if we perform that subtraction, we end up with 0.264 as our result. And so now we look at the 2 numbers. we can see that we are accurate to the thousandths place and to the tenths place. So that means we're going to have to round off to the nearest tenth once again. So we look at the 6, it causes us to round up to 0.3. So that's the answer that we would have to report. So you can see here we end up with just one significant figure, even though we subtracted numbers that had significantly more significant figures, excuse the pun there, than our final answer. For the last one, before subtracting these numbers, we're going to want to convert that second number into standard form so that we can get a better sense as to its accuracy. So, and perform this subtraction. So I've got to move the decimal 2 places, so 0, 0, 4, 2. So now we can go ahead and subtract those numbers as they are, and so we get an answer of 0.3758. But now we look at the two numbers as they are written in standard form, so we can see here that trailing 0 is significant, so we're accurate to the thousandths place. Here we're accurate to the 10,000ths place, so the thousandths place is what we're going to have to round to, so that's going to be right here. So that 8 causes us to round up, so we get an answer of 0.376, and so we have 3 significant figures in our answer. Fortunately for some of you, and you know who you are, the rules for multiplying and dividing are simpler than they are for addition and subtraction. We're still going to start off the same way we did with the addition and subtraction, where we're just going to take the numbers as they are and multiply them or divide them. So in the case, in the first example, if we multiply those two numbers together, we get 413.35. But now, instead of looking at the original numbers to see what was the least accurate place, we're now just going to count how many significant figures each of those numbers had, and whichever one had the smaller number of significant figures, that's how many significant figures our answer is going to have. So in this case, we have 4 significant figures in the first number, we have 3 in the second, so that means our answer is going to have 3 significant figures. So we take our number here, round it off, and so we end up with 413. And again, remember, we don't need to put that decimal point afterwards. It's not wrong if you do. You only need that decimal point to indicate that the 3 is significant if that 3 had been a 0. But otherwise, we can just write the number as is, and we know that 3 is significant. For the last example, 54.8 divided by 12. So if we divide those numbers, we get 4.56, and that 6 is repeating forever and ever. And so we look at those original two numbers. We see 3 significant figures on the top over the 2 significant figures on the bottom. So we're going to round off to 2 significant figures. So our result is 4.6.